This is my Arduino 101 Term 3 project. So I took 3 of the tutorials, the LCD screen, the motor tutorial using a transistor, and the Pzo tutorial. So this alarm clock is set to go off at exactly 8 o'clock. This isn't real time, but this is the time I set the clock to start. It was at 7 hours and 59 minutes. And once it gets to 8 o'clock even on May 13th, 2017, the alarm will go off for 5 seconds, which this motor will go off, and this Pzo Buzzer, which is motion, light, and sound. So the LCD screen is connected to the Arduino board, either the pins on the Arduino board or the positive and negative rail of the Arduino breadboard. It's also attached to this 10K potentiometer, which controls the contrast of the screen. So that's the alarm going off. It goes off for 5 seconds, and it went off a second earlier that time. I'm not sure why, but it does that every once in a while. And we ran into some problems with the motor, with the power distribution in the board. It would mess up the LCD screen's values after the motor went off. So we actually had to insert a capacitor, which is right there, and that's connected to the collector on the transistor. And so that is the whole circuit together. The whole alarm clock setup. This is my breadboard diagram of the fritzing. It makes the circuit as a whole a little bit clearer. So first, the 3.3 volt pin provides power, and the ground pin, which is positive and negative rails on the Arduino breadboard. So I'd say the first thing, this is the LCD screen, which actually broadcasts the time on the alarm clock, or it's like the visual part of the alarm clock. And these are just all the hookups, like power, ground, another power and ground for like the backlight. This is for basically like the computations and like the numbers that show up. So that's the power. And these are more grounds. And this pin right here goes to the potentiometer to control the contrast of the lighting on the LCD screen. And all these, this one, and this one, they all go to the pins on the board, which are connected and through code, and they're given certain values like the time and stuff, and that's how they basically present values onto the LCD screen. And second, this is a bit messy. The second component is the Pzo Buzzer, and this is connected to pin 7 on the board. And so basically, as an output, it's just when the alarm goes off, it'll run current to pin 7 and go through, and it will make the 1000 hertz noise. And then this is the ground going to the negative rail, then eventually back to the Arduino ground. Then this is the potentiometer, and they're both connected to the ground. So it's basically like how much current is allowed through, and that controls the contrast of the board. Lastly, is I have this BC337 NPN transistor, and since it doesn't really receive enough power from the 3.3 volt outing, or the 3.3 volt pin on the board, I connected to the 5 volt pin for extra power, And so basically, the collector brings in the power, and then the base, when that current goes on, it allows power through the transistor, and then the current will come through the other side into the positive lead on the motor, and then will spin the motor, and then it is connected to the negative rail and back to the ground. We got some funky stuff that kept happening after the motor would go off with the power. Regarding the LCD board, it would just make like random numbers and stuff after the alarm went off. So I put a capacitor on it, and that fixed that. So this is a 33 farad capacitor with 35 volt capacity. And this is my Arduino 101 schematic for the circuit. Only first thing. So the 3.3 volt power source goes straight directly into 2 pins in the LCD screen. They're both, one's called VDD and the other one's called LED plus, which refers to plus power. So those are where the power comes from. These 4 pins right here are the pins connected to the actual Arduino board, which give it values to function as a clock, so it can show the time and date. One of these power sources is for the backlighting of the LCD, and the other one is for the actual characters that light up. This green here is the potentiometer that controls the contrast of the board, and then based on the resistance it encounters, it will brighten or darken the screen. And all the blue you see here, 1, 2, 3, 4 pins, they are all connected to the common ground also it's the same with the potentiometer, and they all go back to the Arduino ground pin. So this purple pin here, on pin 7, it goes to the Pzo Buzzer, which will make the alarm tone, the 1000 hertz sound, and then the ground goes back to the Arduino. Next is motor pin 9 right here, and there's the other green pin, and it first goes to the BC337 NPN transistor that comes in the kit, and the base is what opens the reservoir for power. So the transistor is connected with 5 volt for a separate power source from the LCD screen because it needs more power to spin. And the base it provides power to the base. It's like a low voltage, and it opens the reservoir for the bigger voltage in the collector. And then the emitter then will the current will then transfer through to the emitter and then go to the actual DC motor. DC motor is connected in parallel with a 33 microfarad capacitor with a capacity of 35 volts. And the reason why it's connected in parallel is because the typical DC motor consists of coils and brushes and magnets, and the current through the coils pushes them from one magnet to the other. It turns on and off, and in a cycle, and to push the coils to the next magnet. And since you're switching the coils on and off, the current drain on the battery jumps up and down. When it is high, it will waste the energy heating the battery due to internal resistance, and this is what was messing with the LCD screen and giving it funky values after the alarm clock. The motor would stop spinning, and the capacitor acts as a reservoir and buffer so that when the motor draws less current or a small amount of current, the cap recharges and the power is flowing to that instead. And when the motor needs high current, the capacitor discharges through the motor. And then these are both connected in parallel and then to the common ground on the Arduino pin. Thank you.
1.
This is my Arduino code for my Arduino 101 alarm clock from the SparkFun Inventor Kit. First thing I did was copy the code from the tutorial on the sparkfun.com for the LCD screen. And that's like this here, this, and it's basically just using the library. It was very helpful to use the Arduino library for this one. So I set all the integers for year, month, day, hour, minute, second, alarm time, and it required unsigned long time to work with this program, as I'll explain in a little while. And then the second time, which is the alarm time pretty much. Then I set the buzzer pin equal to pin 7 on the Arduino board and motor pin equal to motor pin 9, or just pin 9. And this instantiates the LCD, which basically just provides the layout for it. This pin mode, this just puts the motor as an output for the beginning, just so it's clear. And basically this is all just putting like what the dimensions of the LCD screen are, and for the integers I put in my date. Here's the date that the alarm clock will start at as soon as it starts, and then this is the actual time the alarm goes off. So I put 7 hours and 59 minutes for the starting time, and then it would go off a minute later at 8 o'clock exactly. This isn't real time. This is kind of just when I want to start the Arduino. I could like plug in real time, and it would function as a regular alarm clock. So the set time is the time to begin, and that's program that with all these different numbers. And this just means that if the alarm clock isn't going off, then the voltage to the motor pin will be low, which means it'll be off. How it started was it used millis, which is milliseconds, like the amount of milliseconds since the Arduino has started. And yeah, and then it's divided by 1,000. The second time, which I showed you up there, is just programmed as a function of minute times 60, hour times 3600. So it's all in seconds. It counts in seconds. And second time plus time, alarm time equal to second alarm second plus alarm minute plus alarm hour. Plus 2.5 because it has a little slight bit of delay because it starts at a 1970 for about 2 seconds. And then it goes to whatever date you set on the alarm clock. And I actually serial printed the second time, which I can show you. Let's see. So yeah, it's been running for a while now. So the second time is basically the time in seconds that the clock is running, and if the time gets to the value of the alarm time I set earlier, which was 8 o'clock, so there's an if loop, and it says the tone, which is the Pzo buzzer pin, will go off at a frequency of 1,000 hertz for 5,000 milliseconds, which is 5 seconds, and then the motor pin will go on high, which means the motor will turn on, and It has a delay of 5,000 milliseconds, which is also 5 seconds. So it'll go off for 5 seconds and then it will turn off. And this is basically just other stuff from the Arduino library, setting up the LCD screen properly and basically creating a flow for the date and time and everything, so it actually functions as a real alarm clock. So prints clock time, date time, and yeah, this means that the date starts on the first row, and this starts on the second row, or is row 0 or row 1, and it prints the clock time and date time. Alright, thank you, bye.
This Arduino alarm clock has many uses. The motor on this alarm clock could be used for raising blinds in your room as you're awake, or as you're about to be awake. Also, the Pzo Buzzer doesn't have to play one single tone. It could be made into a melody or any type of song you would like. It's all based on what you want. That is it going off. Yeah, so this project can be put to many good uses, especially with the motor acting along with the Arduino itself.